All right, so these are our practice problems for Chapter 7. So we're going to start off with looking at probabilities using z-scores. So this problem asks us, what proportion of the normal distribution has a z-score of 1 or greater? So if you draw that out, we've got our lovely normal bell curve here. 0, of course, is always our mean, and 1 is the z-score that is being asked here in the question. So it's asking us for this piece that is shaded in the distribution here. So what probability is associated with a z-score of 1 or greater? So that's looking at the right side of the distribution. In order to find that, we're going to look at the z-table, and we're going to look at the z to infinity column, because that is what we are interested in here. So this is our z-score, and we want from z to infinity to the end of the distribution. So we're going to look for our z to infinity column to find our probability. So if you go on your z-table that I have posted online on Moodle, let me go ahead and share my screen so you can follow along with me. Okay. So here's my screen. Here's my desktop, my desktop z-table here. So we're looking for a z-score of 1. That is the z-score that we're working with here. And here is our z to infinity column. That's the column that we're interested in. So we scroll down and we look for our z-score of 1 right here. That is our z column here. So we find z of 1. And our z to infinity, if we scroll across here, our value there is 0.1587. So that is the value that we are interested in because it falls in the z to infinity column here. So let me stop sharing. There we go. Okay. So that's our answer for that one. 0.1587, or if you want to convert it to a percentage, that would be 15.87%. So what that's saying is 15.87% of the distribution is associated with this black shaded region here. Another way of saying that is you have a 15.87% chance of getting a z-score of 1 or greater. So that's how you would work a problem like that. All right, now we have some more examples here. So the prompt asks us, find the proportion of the distribution associated with the following z-scores. So this first one asks us to find what proportion of the distribution is associated with a z-score of 0.80 or higher. The reason I know that is because we have our greater than sign, and greater than means higher. So basically, my advice to you when doing these types of problems is to draw everything out so that you can visually see what's happening. So for this one, it's going to look like this. It's asking us, we've got our lovely bell curve. We have our mean, always 0. Our z-score that we're looking at is 0.80 here. This is asking us for the proportion of the distribution that is greater than 0.80, so that is going to be to the right of our distribution. So we're interested in this bit here. So that shaded region. In order to find that probability, the column that I would look for in the z distribution would be, again, my z to infinity, which is column C in your z table. So let's go ahead and go to the z table and look to see what that probability is. We're going to share my desktop. Okay, so the z-score that we're interested in here, we look here for our column A for our z-scores. Here we find, it continues here for 0.80. This is the z-score that we're interested in, 0.80. And again, we're interested in our z to infinity column, column C. So here's our z-score. We travel over to find our probability, and in this case, it's 0.2119. So 0.2119 is our answer there. So let me stop sharing so you can see there. Okay. So in this case, the probability of obtaining a z-score of 0.880 or greater is 0.2119 or 21.19%. Another way of saying that is 21.19% of the distribution is associated with the z-score of 0.80 or greater. So that's how you do that first one. Next one asks us to find what is the z-score that is associated with 0.25 or less. So we're looking for the left side of the distribution because we have the less than sign. So we're looking for the z-score that is associated with less than 0.25. Let me redraw that, it's not very pretty. Again, we always have our 0 in the middle. 0.25 is really close to the mean, so it's going to be like right here. So that's looking at the left-hand side of the distribution. Or I'm sorry, this is 0.25 on the positive side, not the negative side. Sorry about that. So we're still working with the positive side. Again, 0 in the middle. 0.25, still very close to the mean, but we're at the right side of the mean. 0.25. So that's the z-score that we are interested in, 0.25. The problem asks, what is the probability of obtaining 0.25 or less? So that means that we're interested in the left side of the distribution. So that means we're interested in this stuff here. So for this type of problem, it's a little trickier. We got a few things happening here. There are a few different ways that you can work this. One way that you can work this is by saying that, as we talked about in our Chapter 7 lecture, remember that probability ranges from 0 to 1. And if you think of the bell curve as 100% probability, the whole thing is 1. And if you cut it in half, each side is 0.5. So 0.5 over here, 0.5 over here. So the first way that you can find this is by saying, well, from 0 on the left side is 0.5. So that's part of our answer. Let me get another color here. So that's part of our answer. That gives us from 0 over 0.5. Now we want to find the little bit of the distribution that is from 0.25 to 0. And it's not very much. So what we need to do in order to find that is look at the mean to z column in our z distribution table. So that's going to be our mean to z column, which is column B. That's going to give us what proportion of the distribution falls between 0 and 0.25, which is a really, really tiny piece. So it'll probably be a very small number. So let's go ahead and move to the z table and see what the number actually is. Okay, so here's our z table. So now we're looking for a z-score of 0.25. We look here, here it is. Now we are working with the mean to z column, which is our B column here. So if we look at our z-score of 0.25, and our B column is our mean to z column, we see that the proportion that's associated with that is 0.0987. So in order to complete this problem, all you would do is add 0.5, which was half of the distribution, plus this 0.0987, and that gives you your answer. So let me stop sharing so we can see the screen better. So when you do that addition, let me get my calculator. So when you do that addition, 0.5 plus 0.0987 gives us 0.5987. That's our answer. So what that's saying is 59.87% of the distribution is associated with a z-score of 0.25 or less. So that's how you would do that. Another way that you can work this problem, and let me scoot my camera over a smidge so we have more board room. So another way to work this problem is to think about how the pieces of my distribution work. So you can do it by adding 0.5, or remember that here's our 0. Remember that the whole thing is 1, right? Probability ranges from 0 to 1. The whole distribution is 1. On each side of the mean, we have 0.5. The z-score that we're interested in is 0.25. So another way that you could do this is find z to infinity. So go the other way. So this blue piece here, you can find this number and subtract it from 1, because remember that this is the other piece of the distribution. So if we go 1 minus whatever our z to infinity is, it will give us the blue piece. So let's look at our z-table and see what that number is. So we've got our 0.25 again is our z score. We're now looking at column C because we are interested in z to infinity. So here our probability is 0.4013. That is our column C here. So 0.25. Our probability is 0.4013. So when you do that subtraction, we should get the same answer, hopefully. We'll see. And we do, we get the same answer, 0.57, or 59, I'm sorry, 87. So no matter how you do it, you get the same answer. Whether you want to add 0.5 or subtract from 1, you still get the same answer. So depending on whether you want to use your z to infinity column or your your mean to z column or your z to infinity column, that doesn't matter, just as long as you understand the concept of this and how to use those two columns properly. That's really what we're interested in. So that's A and B. Now let's move on to C. So this one is asking us what proportion of the z distribution is associated with a z-score of negative 0.15 or less. So this one's going to be pretty simple. Again, draw out your distribution. Of course, 0 always falls in the middle. Now we're on the left side of the distribution, so we've got negative 1.5. So this is asking for what proportion of the distribution is less than negative 1.5. So that's our left side. So that's this bit here. So how do we find that? What column? It's going to be our z to infinity column. So even though this is still working with our negative numbers, remember that our z distribution is absolute values. So it doesn't matter that it's a negative number, we're still going to use our z to infinity column because we're interested in the extremes of the distribution. We're interested in the edges. So let's see from our z table what number that is. Okay, so now we are looking for a z of 1.5. So we scroll down here, we find it, 1.5. And we're still wanting our z to infinity, and we see that our proportion that's associated with that is 0.0668. So see here, C column. Excuse me. So our proportion is 0.0668. Okay, so the answer that we got for that one was 0.0668 or 6.68%. So basically what that's saying is 6.68% of the distribution is associated with a z-score of negative 1.5 or less. So that's how you work that kind of problem. All right, now we have a few more examples of this. So we're still finding the proportion of the distribution associated with the following z-scores. We just have a few more examples. So this one is asking for what proportion of the distribution is greater than a z-score of negative 0.75. So let's go ahead and draw that out. Like I said before, you're always going to want to draw these out so you can visualize what's happening. So there's my curve. There's my 0. We always want to put that in the middle first. So this z-score is negative, so it's on the left side. It's somewhat close to the mean, so it's like about here-ish, negative 0.75. So this question is asking us what proportion of the distribution is greater than this, this z-score of negative 0.75. So basically what that's asking for is everything to the right of that z-score. So from 0.75 on the negative side over. So again, we've got two different ways to do this. Let me use some different colors to kind of illustrate what's happening here. I didn't do that before. So the first thing we can do is we can find the distance between negative 0.75 and 0. We're going to denote this with red. Then we can find the proportion of the distribution that is associated with 0 to infinity, which I said earlier was 0.5. So we're going to denote that in blue. That's the first way that you can work this type of problem, is find your red piece and then find your blue piece and then add them together to give you your answer. So let's go ahead and find the distribution, the piece of the distribution between 0.75 and 0. And the way we would find that is by using column B. So our mean to Z column. Put that in red. So mean to Z. So let's go ahead and hop on our Z table. So the Z-score that we are interested in is 0.75. So here is our Z column, 0.75 is our Z-score. We're now interested in Z to infinity, so we want column B. Here is our proportion, 0.2734. So that is the proportion of the distribution shaded in red. So now that we have the red piece, all we have to do is add the blue piece. So 0.2734, and remember what I said about the blue piece. The proportion of the distribution between 0 to infinity is always 0.5. 0 to infinity equals 0.5. So if we add 0.5 to this, this gives us our answer. And we get 0.7734 when we do that. Or 77.34%. So what that's saying is 77.34% of the distribution is associated with a z-score of negative 0.75 or greater. The other way that you can work this, like we did with the other one, is to find the other side of the distribution and subtract it from 1. So let's shade that in with a different color. So here is the green piece. So another way that you can work this problem, or here, another way you can work this, is by finding z to infinity on the left side, so 0.75 to infinity on the left side, and subtracting that from 1. So here we can go z to infinity for 0.75 to give us the green piece. So here again, we've got our 0.75. Now we're interested in column C, which we find here is 0.2266. So that is the probability associated with the green piece. 0.2266. There's kind of a glare, so that's what it says if you can't see it. So now you're going to take that number and subtract it from 1 so that we can get the other piece, because that's what we're really interested in. We're interested in the addition of red and blue. So in order to find that, we've got to take the whole thing and subtract it from green. So remember that probability ranges from 0 to 1. So the whole probability of the whole thing is 1. We're going to subtract the green piece because we don't want the green piece. 2.2266. When we do that subtraction, 1 minus 0.2266, we get the same answer, 0.7734. So you can get this answer either way. So you can do it by adding 0.5 or subtracting from 1, and you get the same answer. Again, just make sure that you are looking at the correct columns in the z table when you're doing this. Okay, so the last one asks us, what proportion of the distribution is associated with a z-score of 1.5 or less? So let's draw that out. We've got our 0 there, 1.5 over here-ish. So we are in the positive side of things. However, because we are looking for a z-score of less than 1.5, we're interested in the left side of the distribution, so everything that falls to the left of 1.5. So again, we set this up very similar to what we did up here. So one way that you can work this is to find the space between 0 and 1.5, which we'll denote here again in red. And that, of course, is going to be our mean to z. And then you can add that to your mean to infinity column. Your mean to infinity proportion, I guess. So we are interested in what piece of the distribution is both red and blue. We're interested in the left side of the distribution. So first we find the red piece by going to the mean to z column. So let's do that first. So the z-score that we are interested in is 1.5, which we see here. Our mean to z column, which is what we are interested in right now. We see that up here. So that proportion is 0.4332. So in order to get our answer, what do we need to do? We need to add our blue piece. And remember what I said earlier with our blue piece, the proportion from 0 to infinity is always 0.5. So we just add 0.5 to that. So 0.4332 plus 0.5 gives us 0.9332. Or 93.32%. So the way you interpret that is by saying 93.32% of the distribution is associated with a z-score of 1.5 or less. Again, you can find this by doing it the other way. You can find the green piece by doing z to infinity and subtracting by 1. So let's do that as well. So we can find the green piece and then subtract from 1 to also get the same answer. So in order to do that, we need to do our z to infinity. So for 1.5, our z to infinity, we found this earlier, but let's go ahead and find it again. 1.5 is our z-score. We're looking at our z to infinity column, which is column C. We see here that our proportion is 0.0668. So we see that our proportion of the distribution that is in green is 0.0668. So now all we got to do is subtract 1, which is our total probability, the whole thing, from the green, which is 0.0668, and we get the same answer. 1 minus 0.0668 gives us the same answer, 0.9332, or 93.32%. So that's that. Okay, now we're going to do a problem that's a little bit different, but it's really important that we understand these types as well. So with these, we are taking raw data and we are converting it to z-scores and then finding the probability of those z-scores. So the problem asks us, or tells us, that the average driving speed is an average of 58 miles per hour with a standard deviation of 10 miles per hour. What proportion of drivers drive between 55 and 65 miles per hour? So what we're going to do here is we're going to find out what these two raw scores are in z-scores. So we're going to convert these two raw scores to z-scores, and then we're going to find the proportion of the distribution between these two z-scores. So this is like a two-step problem. So the first thing that we are going to do is we're going to work from our z-score formula, which I'll write up here for reference. So we are kind of adding on to our last lesson where we use this formula here, z equals raw score minus mean over standard deviation, and we're just adding a little bit more to our steps here. So the first thing we're going to do is we're going to convert this raw score of 55 into a z-score. So 55 minus our mean, which is 58, over our standard deviation, which is 10. So that's going to give us our z-score for the raw score of 55. So 55 minus 58 gives us -3 over 10, which gives us a -0.3. So that is our first z-score. So -0.3 is the z-score associated with the raw score of 55 miles per hour. Now we're going to convert this z-score, or convert that raw score into a z-score. 65 minus 58, because again, that's our mean, over 10, because again, that's our standard deviation. So we do this subtraction, 65 minus 58 gives us 7 over 10, which gives us 0.7. So those are our z-scores. We've got a negative 0.3 and a positive 0.7. So let's draw that out so we can talk about conceptually what this problem is asking us to do. So again, we've got our lovely bell curve. 0 is our center. Here is our 55 miles per hour point. So our negative 0.3 z-score. Negative 0.3. So that's where that falls. 0.7 falls over here. So what this problem is asking us to do is to find what proportion of the distribution falls between the red line and the blue line, between this point and this point. So again, there are a few different ways we can do this, but this is the easiest way to do it. The easiest way to do it is to find the proportion that is associated with this piece here, our mean to z, and our mean to z. So the easiest way to do this is to find mean to z for both of these scores. So find mean to z for 0.3 and mean to z for 0.7 and add them together. So let's go to our z table. So mean to z for a z-score of 0.7 is right here, 0.7. And we are, of course, interested in our mean to z, which is column B. So we see that the proportion that is associated with that is 0.2580. So that is our blue piece. So that is our mean to z for that piece. Now let's find the red piece. So now we're going to look at the z table for 0.3. So 0.3 right there. We're again looking at our z to infinity, and we see that the proportion that's associated with that is 0.1179. So that's our red piece. Okay, so those are the numbers that we are working with, our proportions. So here we've got 0.2580, and here we've got 0.1179. So those are our red pieces and blue pieces. So now all we've got to do is add them together to give us our answer. So 1179 plus 0.2580. When we add those together, we get 0.3759. Or 37.59%. So what that's saying is 37.59% of drivers drive between the speeds of 55 and 65 miles per hour. So that's how you would work a problem like that. You convert the raw scores to z-scores, and then you find the probability that's associated with those z-scores. So again, it's really helpful to draw everything out so that you're understanding what the problem is asking for and what you need to do with it. Okay, so the last one that we're going to talk about is how we take how we do a problem like this, where we are given percentages and we're asked to then go to the z-table to find what z-score is associated with a given percentage. So this asks us what z-score separates the top 25% of the distribution from the bottom 75% of the distribution. So again, I always suggest to write this stuff out so that we understand what's happening. So this is asking us if this is half. This is asking us about this point here. Let me make that a little more accurate. Okay, so this problem is asking us what z-score is associated, so what score do we need to put here that divides the top 25% of the distribution from the rest? So the way that we do that is we are going to first convert this percentage to a decimal, because that's what our z-table works with. So we're going to go 25%. And we're going to, whoop, whoop. So now we're looking for 0.25 in our Z table. So now the next question is, what column would we need to look for to find this value? Well, we're interested in the Z-score that separates this from this. So we're looking at this shaded piece of the distribution. So when we're doing the ends of the distribution, we're always going to be working with the z to infinity. So we're going to look for, in the z to infinity column on the z table, we're going to look for a 0.25. Whatever number is closest to a 0.25 in our z to infinity column. Not a very pretty infinity symbol, but that's okay. So we're going to look at our z-table to find what z-score has, what z-score is closest to the value of 0.25 in the z-table. So here's our z-table. So we're looking at our z to infinity column over here, and we're looking for the value that is closest to 0.25. So we see here that the closest that we get is 0.2514. So we look at the z-score that's associated with that, and we see that that is 0.67. So although we don't have a 0.2500, we have a 0.2514. That's pretty close. So we're going to go ahead and say that the z-score that is associated with the top 25% of the distribution is 0.67. So let's go to the board and show you that. So 0.67. That's the z-score that is associated with the top 25% of the distribution. So that's how you would do a problem like that. It's basically kind of working backwards from what we've done in the past.